Alright, so this is section 4.6. It's graphing with calculators and calculus, and the theme is really the interaction between the two, the calculus and the calculators. So knowing how to use the first derivative, the second derivative, and the information that it gives as far as the max and mins and the intervals of concavity and all that kind of thing, not to be tricked by what the calculator appears to show you, but the two together really is powerful. Okay, so I'm going to kind of go small screen so that I can actually, fit the calculator here. All right, so let's start with the function 2x to the 6th. Let me actually write it here. So let's go example 1, and let's go ahead and graph f of x equals 2x to the 6th plus 3x to the 5th. So we'll go ahead and just enter that into your calculator. And make this a little bigger. Let's see. Make this cubed minus 2x squared. So go ahead and plug that into your calculator. Make it small again. And I went ahead and plugged that into my calculator, and I pressed Zoom 6, and it didn't really show a great graph. And so what I want to do is I'm going to just go ahead and mess around and do a -5 as the min, +5, and then I'm going to go zoom and then fit. Sometimes you can go zoom fit, and it tries to find a range that makes some sense. So zoom fit picks a suitable range. So let's take a look at it. It might be a little bit slow. And the problem is, though, it looks kind of looks like 2x to the 6th. If you look at it, it looks like 2x to the 6th. It doesn't look like it has any of the zeros that we should be getting out of it, especially the odd powers there should be probably giving us a 0 or something. So what I'm going to do is I'm going to change the window. So again, I'm just kind of messing around with it. I'm going to say -3 as my x min, and then 2 as my x max. And then I'm going to change the y min to be -20, and then the y max to be 20. Regraph, see what that looks like. And I think this is a pretty good sketch. I guess it's not all that much different than the Zoom 6 initially. And so when I look at this, I could probably calculate what the absolute min is. So see that low point? I'm sure you guys. Oops. Yeah. 1 sec. You see that low point? Whoa. The low point right there. And so what I'm going to do is I'm going to go ahead and just calculate that. So second calc, do minimum. And remember how this works, you have to move it so that it's a little bit to the left of the 0, or left of the minimum. And then press enter, and then move it so it's a little bit to the right. Press enter again, guess. Should calculate the minimum for me. So it looks like the minimum is right at negative, let's say there's a minimum at negative 1.62, comma, negative 15.33. Okay? So according to the calculator right now. And then if I did the trace button to try to figure out when it's increasing and decreasing, it looks like from negative 1 point, go around again to 1.62. This whole time it looks like it's decreasing. And then when I get to that min right there, then it looks like pretty much as I go up, it looks like it's increasing the whole time. At least that's what it appears. And that is going to turn out to be incorrect. So we're going to do a couple of things here. So first thing is let's try to use the calculator to give us the min, but let's use calculus. So first, let's go ahead and calculate the first derivative and the second derivative. So let's just go ahead and write that down. The first derivative, let's see, make this a little bigger. All right, so first derivative, let's calculate it. So first derivative, that would be 12, just use the power rule, 12x to the 5th plus 15x to the 4th plus 9x squared, and then we got our minus 4x. Okay, first derivative. And then let's go ahead and find the second derivative. So f double prime of x would be 60x to the 4th plus 60x cubed plus 18x and then minus 4. Okay, so what I'm going to do is I'm going to go ahead and just plug that into the calculator, and I actually already did, and I'm going to go ahead and unhighlight it. So when you do this, just go ahead and unhighlight the original function so you can really focus on the one you're looking at. So I'm graphing the first derivative, and I'm going to be looking for sign changes. And so I see a sign change, right here. So I'm going to go, it looks like it's in between -1 and 2, so I can go second calc, and I'm basically finding the 0 there, right? So I need to move it to the left. See if we get the same thing we got when we calculated it before. And then right, a little bit to the right, and enter. So that gives me a 0. Let's see, that's -1.61. That's my x coordinate. Rounded, it would be -1.62, like you said. And then let's say I want the y coordinate, because obviously I need to plug that back in. So what I do is I go y equals, and I go ahead and I unhighlight that, or highlight it. And then I can go to the second table, and I can just plug that x value in. So let's say I want to plug in -1.62, enter. And then I just look at the y1 there, and I can see that the y coordinate is indeed -15.33. So that's a really good way of, using the calculator to get some max and mins. And so let's see. Let's go back to our graph. And so we kind of verified that one. But let's go back and look at it again, because I think there is another sign change that we didn't notice before. So if you look right here at 0, it looks like it definitely dips below the x-axis. So that actually means that there's another 0 there. And so I think you can probably tell where it is. So that's the left side of it. And then I would move my cursor so that it definitely got below. You can see the negative y coordinate, -0.27. So it got below. And then it looks like right there at 0. Right there at 0, 0. So we actually have, and if you look at the graph, we have a sign change. It goes from positive to negative. So that means there's actually a max at 0. And of course, you can look at the original function, and if you plugged in a 0 there, you get 0. So at 0, 0, there's actually a max that we didn't really see before. And then there's another sign change. You can see right there it goes from negative to positive. And so you can see where that is. So we just need to be to the left of it, which it is, it's negative. And then we move to the right of it. And we see that there's a sign change. It goes from negative to positive right there at 0.35. This is the first derivative we're talking about. So it goes from negative to positive, which means that there's a minimum there. So there's a min. And again, if you wanted to find, the y coordinates that go with that, then you could just, go back to your first derivative or your y1 and just highlight it again so that you can actually plug in those x coordinates. So I'm going to go ahead and kind of recap on our document here what we figured out. So let me get a new sheet. All right. So we looked at the graph and we saw a sign change. So we were looking at f prime of x, and you're looking for f prime of x. Let's say it gave us say to give us some sign changes. All right, so we notice that we went from negative to positive. So we had a min at negative 1.62, comma, negative 15.33. And then we noticed that we went from positive to negative. And that was at 0. So that's a max. And that was 0, 0. And then we noticed we had a sign change. We went from negative to positive, and whenever it goes from negative to positive, that's a min, and that was at 0.35, comma, negative, and I had it round. It turned out to be like 0.09 something, so it was negative 0.10. Okay, so those are the first derivatives. Now, what about the second derivatives? Well, we go to our graph and we go ahead and unhighlight the first derivative. I'm going to highlight the second derivative. So we can go ahead and graph it. And again, so now we're looking at what's going on with the second derivative. So the graph shows, it looks like there are some sign changes. So let's go ahead and figure out that spot where there's a sign change. So we can calculate the 0. So let's go to the left side of that. Okay, on the left side. Move to the right. And it looks like it's negative 1.23 is where that occurs, that sign change. And it goes from positive to negative. So we see that there's actually an inflection point there. Changes from concave up to concave down. And then we have another one. So we go second calc. Let's go to the left side. And move to the right side. And it looks like that is at 0.19. And that changes from negative to positive, so that goes from concave down to concave up. So here's what we get out of that, and then we can get inflection points. We can go again. We can get the y-coordinate just by highlighting the y1, and then simply using our table, remembering what those x-coordinates were. So let's say I plug in negative 1.23, that was one of them. And we can see that y1 was our, gives you the point. It was negative 10.13, so that's the y-coordinate that goes with that. And then the other one was 0.19, so we plug in 0.19, and we see that the y-coordinate that goes with that is negative 0.05. All right, so I'm going to go ahead and write down what we figured out in the calculator. So we saw sign change. So So we're looking for, we saw sign changes, okay? And we saw that it went from, let's see, went from positive to negative. And it was at negative 1.23. So we have an inflection point at negative 1.23, comma, when we plug that in, we got the y-coordinate, negative 10.13, and then we saw it went from, let's see, it was negative to positive, and that was at 0.19. That was negative 0.05 was the y-coordinate that went with that. So of course we can tell, concave up, concave down. These actually are inflection points because there was sign change at these spots. And And you guys know the intervals of concavity. I'll go ahead and write those down as well. But you know, these inflection points kind of separate and give us the intervals of concavity. So let's say we are concave up. So we are concave up on a couple intervals. Let's say I would want to write this concave up on let's see, negative infinity to negative 1.23 union with 0.19 to infinity, because if we looked at the second derivative, that graph was above the x-axis on those intervals. And then we're concave down on, let's see, we're concave down on in between there. So negative 1.23 to 0.19. Okay? All right, so let's see. I think I'm going to go with that.